We all love a good mystery novel or movie. It seems that science loves a good mystery too, because there's so many things about our universe that scientists simply do not know. We can't explain some of the most basic features of our reality, let alone what's out there beyond Earth. Here are 5 great mysteries of space, according to science. If any of these are solved, get ready for a Nobel Prize. The speed of light in a vacuum is constant and is one of the fundamental constants of nature. That means that no matter where you are in the universe, if you were somehow able to measure the speed of light in a vacuum, it would be exactly 299,792,458 meters per second. That might seem obvious. It's not like we're on a train traveling through space. So how fast is light really going? Well, surprisingly, we don't know. While we can measure the speed of light pretty easily here on Earth, we don't actually know its value in other parts of the universe. Since Einstein developed his theory of special relativity in 1905, we have assumed that the speed of light never changes. But what if it does? Scientists have proposed a few different theories to explain what could happen to the speed of light in space. One of those is called variable speed of light, which suggests that the speed of light may have changed over time. This theory would require revision to both general and special relativity. Another theory is that the speed of light changes in different places. This would mean that the universe isn't truly homogeneous, meaning the same everywhere. According to the Big Bang theory, the universe began from a single point and has expanded outwards. If that's true, then the entire universe should look the same no matter where you are in it. There shouldn't be any preferred location. But if the speed of light changes in different locations, then some places will be more fundamental than others. Change in the speed of light would also affect our measurements of the age of the universe and the size of the universe, both of which we already struggle to measure accurately. Dark energy. In 1998, astronomers were studying distant supernovas when they made an incredible discovery. They found that the supernova were dimming less quickly than expected. Now, normally, when we see a supernova, we know how far away it is. We know how bright it would appear if it were close to us. And we know how much light has been dimmed in transit based on the distance to that star and the fact that it took light so long to reach us. The surprise was that these supernovae appeared brighter than expected given their distance. That meant that something must have caused the light to speed up, making the supernova appear more luminous than it really was. Scientists realized that the only thing that could have happened was that the space between the Earth and the supernova had expanded, carrying the light with it. But that's not possible. Space can't expand like that. Space doesn't stretch like a rubber band. It just can't. Space-time expands. And that means that dark energy is real. Dark energy makes up 68% of everything in the universe, but we still don't know what it is. And that's why scientists are struggling to understand the universe itself. Without knowing what dark energy is, we can't know why it's changing the universe at such a rapid pace. And if we can't understand that, then we can't possibly understand our reality. Where are the planet's moons? Looking around the solar system, we notice something strange. Some planets have rings, but almost none of them have moons. Take Saturn, for example. It has only 8 known moons, yet its rings are larger than all of the planet's moons combined. Other planets without rings have multiple moons. Jupiter has 79 moons, Neptune has 14, and even tiny Mars has 2 moons. So why don't the ringed planets have moons? Scientists think that it may have to do with the formation of the rings. According to NASA, planetary rings form when small bodies like comets and asteroids come too close to a planet and are destroyed by its gravitational forces. That would explain why ringed planets don't have moons. Comets and asteroids would be hitting the planets and becoming part of the rings before they could ever coalesce into moons. But that still raises another question. Why are some planets perfectly round while others are not? You can see Uranus and Saturn from Earth, but they both look a little off, like they've been squished vertically. It's probably due to the effects of the rings on the planets. The rings exert a force on the planets, pulling them slightly wider at the equator and making them look a bit squished. The other sideways planets like Jupiter and Neptune don't show this effect because their rings aren't wide enough to have an impact on the planet's shape. Why is the cosmic microwave background so uniform? When the universe began with the Big Bang, everything was hot and dense and very, very small. Over billions of years, everything has expanded, cooled, and spread out. That would make sense. But it doesn't explain why the cosmic microwave background radiation, which is left over from the Big Bang, is so uniform. This radiation should have taken millions of years to spread evenly across the universe. And by the time it reached us, it should have been filled with a lot of variations depending on where it came from. But that's not the case. The cosmic microwave background radiation is nearly identical no matter where you look in the sky. It's uniform within 1 part in 100,000. And scientists don't know why. The best guess is that there was some mechanism for the early universe to share heat with its neighbors, until everything reached thermal equilibrium. But what could that mechanism have been? Scientists have a few guesses, but no one knows for sure. Why did life begin on Earth? We are alive today because conditions on Earth were just right for life to begin. We had liquid water, a magnetic field, an atmosphere, and a stable climate. All of those things were necessary for life to arise naturally. But scientists don't know why those conditions were present on Earth. Sure, we know that the conditions were somewhat unique. Earth is the only planet in the solar system with all of these things, but we still don't know how it happened. Was Earth struck by a comet that brought the necessary ingredients for life? Did life arise naturally from non-living things? Did life come from somewhere else? Scientists do know that life arose relatively quickly after Earth formed. Most scientists agree that life first appeared between 3.8 and 3.6 billion years ago. But how did life begin? How did organic molecules become cells? Scientists are trying to answer that question by conducting experiments on early Earth conditions and by looking for signs of life on other planets. What's the heaviest element in the universe? Elements are defined by the number of protons in their nuclei. That means that hydrogen, the lightest element, has 1 proton, while helium has 2 and lithium has 3. But there's a problem with this definition. Scientists have found evidence of elements in space that have more protons than we thought were physically possible. In 2022, researchers announced the discovery of a star with more than 100 protons. That discovery raised a lot of questions, including how many protons can exist in an atom. The answer to that question could change our understanding of physics. Each proton carries a positive electric charge. So as you add more and more protons to an atom, the nucleus becomes more and more positively charged. At some point, those positively charged protons start repelling each other. That repulsion should prevent more protons from being added to the nucleus. But scientists have found evidence of superheavy elements with hundreds of protons, and they still don't know how. There are 2 main ideas for how atoms can continue to add protons. The first is that there's some unknown force that counteracts the electromagnetic force and holds the protons together. The second is that there's some unknown type of matter that makes up the majority of the atom's mass, and it's not protons. Either way, there's something we don't know about physics. Now watch. What actually is the universe? Or check out. Do aliens exist? Surprisingly real evidence?